Yes, hello everyone. Allow me share my screen so that we can start. My name is Mugabe Samuel, and I'll be taking you through this paper that I reviewed. It's on the topic of bike sharing demand prediction at community level under COVID-19 using deep learning. Mainly what the paper was suggesting is a hybrid model of deep learning, combining convolutional neural networks together with a long short-term memory LSTMs to get the best out of this. And this was compared to ARIMA models, of which it showed that it outperforms the ARIMA models. We have the table of contents there and the introduction, which I'll not spend much time about it, but bike sharing has been around for some time, and most cities are adopting it because of its sustainability in urban areas and also it being eco-friendly. But in there arise issues of bike imbalance, and this is not a common trend with bike share system. Bike imbalance is always there. So this study gives a short-term prediction in a horizon of about 15 minutes. It predicts in 15 minutes, giving real-time information, real-time prediction in a way that is feasible to the operations of the bike share system. In the related works, the paper suggests and it gives articles that were reviewed, but in there, of course, the main issues that arose were the potential of hybrid learning models to support, more accurate and short-term forecasting of bike sharing demand. That prediction is needed as early as possible, so rebalancing can be taken on. A method to aggregate bike sharing stations to address the challenge of evolving network configurations as well as interactions between stations. That's another gap that was identified from the literature review, and also implementing a predictive model that with important disruptions in historical data because of COVID-19, which is mainly what this paper is about. We feed the models with history data. Now, the modeling approach for this paper is mainly around community detection, clustering. The communities are in Montreal. I think it's a state in Canada. It was, the communities were clustered, they were grouped. They were grouped using a method called Lovian method, as we shall see in front. And then there was data structure design, in which the data was designed, and then the deep learning models were applied. Let's talk about the community detection. Now, this community detection, it was mainly brought in using the Lovian method, which has two steps in optimizing to identify those clusters, those community clusters. Firstly, it gives a modularity in which it allows each node to move to join a community that is directly its neighbor. The nodes were the stations. So these stations move to all community. As a station belongs to a community of its neighboring nodes. That's the first thing you should know. Then secondly, it identifies communities that are aggregated into super nodes to construct a new network. This aggregation is sort of like a correlation in the mathematical model, a correlation in these nodes. And then after doing these two steps, they are repeated and repeated until the all nodes, all nodes settle in communities. Now this was applied and 5 communities were got out of that Lovian method. The data structure was designed in a matrix format. in a matrix format in which in there it included a mean, it included a maximum, the mean and also the minimum. It included the 70th percentile, the quartile, and all these were included in this data structure. And then next to that, there was also another input that was applied to the data, which of course this input was the historical data containing all the time intervals of the times the transactions took place. Then the target was to separate to separately predict the bike number, the number of bike pickups in each community. That's mainly our target, and that can be achieved through this method of the data. So like we've been talking about the convolutional neural networks, and these are sort of feed forward neural networks that they've mainly been used in computer vision, in image classification, object detection, and they perform very well. Semantic segmentation, they perform very well there. But this is also what we are using here. Now, these CNNs are typically constructed in three layers. And these are mainly the convolution layer, then there's a pooling layer, and also fully connected. Now, in the convolution layer and the pooling there, they are mainly used to reduce the complexity of the model, and that can be indicated, as you can see, in this equation, where in fact that's the activation function. And now for the LSTM, this mainly means a long short-term memory. It's a type of recurrent neural network, where information is performed sequentially. It's mainly applied to time series data. It's mainly applied to time series data because it has it's capable of forgetting, and also it's capable of remembering what has been fed into it, and then it transfers all that information forward. Now, this information is controlled by the cell state, and this cell state is also determined by what we call a gate, and that's mainly what you should know about these LSTMs. Now, these LSTMs, they are mainly associated with three gates. There are three types of gates that are represented, as you can see in this equation. You have the input gate, you have the forget gate, and then the output gate. Yeah, so mainly that's it with the LSTM. Now, this paper, we are mainly looking at how we can make a hybrid model of the CNN and the LSTMs. So the community structure, we're looking at the BICSI network. BICSI is the bicycle share system that gave us the dataset that was analyzed for this paper. And in these communities, you can see, using the Louvain method, it came up with 6 communities. And the number of stations, you can see, this is per year, the number of stations in each community. For example, this red community has 100 stations in the first year. Still has the same number of stations in the second year, but then the number of stations increase. They increase in 2019. And as you can see, the clusterings of communities here on the map, they're relatively close to each other, according to the color, according to at least what you can see. Yes. So all this was applied to this bike sharing system in in the Bixi system. And as these are some representations of of the the stations, and then the heat map, the heat map on the map showing the intensity of usage and also the number of usage at the different time intervals. You can see the highest peak is around 5, which is typical in a bicycle share system. Now, the models were tested, of course, and the the predictions were were tested against, they were evaluated against mean root mean square error, and also mean absolute error. And as you can see, the different communities. So this was LSTM applied on group 1, LSTM applied on group 2, LSTM applied on group 3, and so on and so forth. And that is how they were evaluated. Allow me jump to the conclusions out of what we observed from this paper. This paper was mainly presenting a hybrid model. It was forwarding a hybrid model for a hybrid architecture to use to predict the demand in short time periods of 15 minutes and so on and so forth. Now, this hybrid model, it was compared to the ARIMA models, and of course it performed better than the ARIMA models, and of course this is what was mainly got from this paper. The other concept that was brought from this paper is the community concept, which I felt was useful in a way that these models are applied to different to similar groupings of docking stations, which I found very helpful. Other than that, thank you so much for listening, and stay blessed.